What if I told you that you could build a hacking tool that types at superhuman speed, executes commands, and takes over a PC, all for under $2? This is the Digispark. It looks like a cheap piece of circuit board, but today we are going to turn it into a devastatingly effective HID tool, just like the famous USB Rubber Ducky. Let's dive in. Before we go any further, a major disclaimer. This video is for educational and ethical hacking purposes only. The techniques shown here are intended to help you understand physical security vulnerabilities so you can better protect yourself. Never use these tools on any computer or network without explicit written permission from the owner. Unauthorized access to computer systems is illegal and can have serious consequences. So, what is it? The Digispark is an incredibly small, Arduino-compatible microcontroller board based on the ATtiny85 chip. It has 6 I/O pins, 8K of flash memory, and the best part? It plugs straight into your USB port. Because it has built-in USB communication, it can emulate human interface devices, also known as HID. That means when you plug it in, your computer thinks it's just a regular keyboard or mouse. Setting this up in the Arduino IDE is a bit different from a standard Arduino Uno. The original Digistump servers went offline a while ago, so here is the updated method to get it working. First, our PC needs to know how to talk to this tiny beast. We need the Digispark drivers. Head to the GitHub link in the description, download the digistump.drivers.zip file and extract it. Run the dpinst64 if you're on a 64-bit system, or dpinst for 32-bit. Pro tip, keep your Digispark plugged in for now. Just let the drivers install. Next up, the brain. We need the Arduino IDE to write our payload. Go to arduino.cc, download the latest version for your operating system and install it. Easy, right? Now let's set it up. Configuring the IDE. Open the Arduino IDE. Go to File, Preferences. See that box that says Additional Boards Manager URLs? Paste the custom GitHub link I've put in the description. The old official link is dead, so this community link is the secret sauce. Now, go to Tools, Board, Boards Manager. Search for Digistump and install the Digistump AVR Boards package. Once that's done, go back to Tools, Board, find the Digistump menu, and select Digispark, default 16.5 MHz. Boom, we're ready to code. But before we write our own script from scratch, let's look at a template. Go to the File menu, select Examples, then Digispark Keyboard, and click on Keyboard. This opens a new Arduino IDE window where you can see the basic Hello Digispark structure. It's a great way to see how the board talks to your computer. Now, to perform our actual demo, we're going to replace that example with our own custom program. Now for the fun part, the attack payload. Since the Digispark acts as a keyboard, we can tell it to press any keys we want. I've written a basic Hello World script to show you the raw power of this $2 board. Here is what our code does. First, we include the DigiKeyboard library. In our loop, we tell it to press the Windows key plus R to open the Run dialog. We add a tiny 500 millisecond delay, type Notepad, and hit Enter. Finally, we tell it to type out a special message for you guys. Let's upload it. First, hit the check mark to verify the code. Our payload uses a tiny footprint well under the 6,000 byte limit. Now, click the Upload button. Watch the console at the bottom. Wait until it says Plug in device now. You have 60 seconds. Plug the Digispark into your USB port. The bootloader catches it, flashes our payload, and bam! It executes instantly. The run box opens, Notepad launches, and it types our message faster than I ever could. That was cool, right? But it can be used in many ways, and today we are going to use it to prank our friends. Let's write a payload that forces their computer into a fake, never-ending Windows update screen. We're changing up the loop. This time, we press Windows plus R, but instead of Notepad, we tell it to type in the URL for fakeupdate.net. It hits Enter to open the browser, waits a second, and then hits F11 to force the browser into full screen mode. We upload it exactly the same way. Now, imagine your friend steps away to grab a coffee. You plug this into their machine, and in under 3 seconds, bam! Their PC is updating, and they're stuck waiting for a progress bar that will never finish.
5 minutes later. 1 hour later. 1 eternity later.
Alright, we've seen the basics, and we've pulled a hilarious prank. But now, I need to show you the real reason why this $2 board is considered dangerous. I'm going to show you why you should never leave your computer unlocked or plug in a random USB drive. This final payload isn't a joke. It's an educational demonstration of how fast your data can be stolen. It's a terrifyingly fast data heist. Remember, only run this on hardware you own. This script is designed to rip your saved Wi-Fi passwords and blast them off your computer to an anonymous server. Here is exactly how this tiny monster operates. The second you plug it in, the clock starts. It waits just 3 seconds, opens the run dialog, and fires up a command prompt. It immediately jumps into your system's hidden temporary folder so you don't see what's happening. Boom! It runs a built-in Windows command that rips every single Wi-Fi password your computer has ever saved. It then uses PowerShell to filter out the junk and saves those passwords into a neat little text file. But here is the truly terrifying part. It fires off one more PowerShell command that instantly uploads that file across the internet to a live webhook server. It literally sends your data across the internet. And before you even process that a black window just flashed on your screen, the script deletes all the evidence to hide its tracks. Finally, it flips on its built-in LED, a tiny red light letting the attacker know the heist was a success. Start to finish? Less than 20 seconds. Your network credentials stolen by a $2 circuit board. That is why physical security matters.
Emotional damage!
Because devices like this exist, you should never plug a random USB drive you found in a parking lot into your computer. To protect yourself against rogue USBs, you can use endpoint security software that blocks unknown USB devices, or simply lock your computer screen when you walk away. If you found this setup guide helpful, drop a like, subscribe for more hardware projects, and let me know in the comments what you plan to automate with your Digispark. See you next time!